to gina-encourage na ko permi sa inyo ha, as much as possible ayaw jud palit sa inyohang submission sa inyohang mga requirements. Kaduha, for reports, prepare a video recording in case trouble suddenly occurred, like unexpected na pagkawala sa internet connection. Kaya para at least di ita maputol sa ato ang discussion. And also, no, nalimot lang kog butang dere, naman tayo reporting karong final term. So, after any nga topic, magpasa ko sa inyo ha og list of topics na i-report sa kada group. Ato rang gamiton tong the same members sa katong gigamit na to sa midterm nga reporting. So, paabot lang sa katong mga topics na akong ihatag sa inyo ha. So, kato, as promised, ang mga reporters are exempted for the quiz. Tapos, kung late lang submission, diha kita na ritay dako nga deductions. I mean, exempted na gani ka, late pa jud ka magpasa, so mura di pud sakto. So please lang, pagpasa gyapon mo sa saktong oras. Balag ka nang moingon mo exempted. Nga buta lang gud ninyo naka Microsoft Word nga exempted. Ana. And lastly, strictly follow the instructions provided on each activities. Failure to follow corresponds to deductions of points. Di lang ko sure kung dari ba to nga section, but na ako'y nakitaan manggod sa midterm exam manggod, di ba ang instructions ato is write the capital letters only. Tama ba ko?
Yes, sir.
Namanggoy uban ato, gisulat yun kung unsay sulod sa letter. So, nakaingon ba gid dito, no points. Ako na lang yun gikuan yun. Ako na lang yun gideductionans na lang, dili na lang kay zero diretso kay sakit kayo. Pero next time, dili na ko mo consider ato ha. So, klaro ba ta aning class rules na to?
Yes, sir.
Crystal clear, sir.
Okay, so let us proceed sa ato ang new topic for the night. So, light and architectural lighting systems. So, morning references nga akong gikwaan para sa karon nga topic and what are the objectives. So, natay 5 objectives para ani. So, una, name, describe, and distinguish between types of artificial and natural lighting sources. Second, identify the influence of color rendition. Third, identify appropriate lighting levels for a specific occupancy. So, kaning sa third no is naamang gud na siya ginatawag nga recommended lighting levels sa let's say kada area sa ato ang residences. So, for example, if study room ka, na kay recommended lighting level na para sa study room. Lahi po na siya kung kuan ka kanang example repair room or even bedroom or kitchen or sa sala. So nana siya ay murag recommended lighting levels para ana. Fourth, perform basic lighting analysis such as single point, zonal cavity, and natural lighting methods. So kani siya sa ika-fourth na objective, direta maka-learn kung unsaan ni nato pag-calculate og pila ka buok ang recommended number of luminaires para sa ato ang area provided na ing ani pod ang kahayag sa suga nga gamiton nato. And lastly, interpret, design, and detailing information on artificial and natural lighting. So here are the contents of our discussion. So kaning discussion is approximately mga 3 meetings ni siya, no? Wait lang. So sa karon nga gabi atong topics nga i-tackles are kani A chronicle of artificial lighting, which consists of historical perspective about sa lightings. Then, what are the professional organizations na involved sa lighting design? Then, what are the standards and codes to be followed? Next is the elements of seeing. So, natay brief discussion about sa visual system and the eye. Third is the light. So, under sa light, natay electromagnetic radiation, visible light, and behavior of light. Fourth is the color of light. So, natay topics about sa iyang perception, quality, and visual acuity. And last topic for the night is the characteristics of artificial lighting. So, dere na to ma-learn kung dere makatuon ta kung unsa day pasabot aning mga lamps, luminaires, and light fixtures. Then, kanina yung mga characteristics about light output, luminous efficacy, correlated color temperature, color rendering index, spectral power distribution data, lamp life, and depreciation of lamp output. So after sa tong pagka next meeting, magsugod din ta aning types of artificial lighting. So ma-discuss na to kung mga lahi-lahi nga klase sa ato ang mga lights na available. Then forms of architectural lighting. Then napo tay lighting installations, light distribution and glare, illuminance and luminance. So dire na mag-start atong mga calculations. Next is the principles of lighting design. And naputay lighting design practices and considerations. Then what are these lighting system controls or how do we control the light? Naputay discussion pod ana. So ang basic control anang lighting system is ang switch man gyud for basic on and off. Then last topic para anihang chapter is the daylighting principles. So roughly, I think, kaning design is mag-start sa third meeting sa karong final term. So, sa inyo unsa inyo hang expected na matun-an ani nga topic nato karong final term? Anyone?
Sir, it's a long question, sir.
Unsa inyong gina-expect nga matun-an ani nga topic kaning natural lighting and kani atong chapter 4 ba? Light and architectural lighting systems.
Kuan, sir. Unsa kanang mga appropriate na suga gamiton bitaw, sir, sa specific na place sa isa ka balay or office ba ka? Ingana.
Maayo nga observation, Kirby. How about ang uban? Anyone else? Okay, so I think sige draw. Same ra kay Kirby, sir. Okay. Sige, so start na ta. So, around 20 to 25% of the electricity consumed in the United States and Canada is all about sa lighting. And almost 20% sa total global electricity consumption is lighting ang ga-compose ana. So lighting makes the objects in the space visible and able to conduct activities that must take place in the space. So, for example, mag-study ka sa imuhang kwarto. So, obviously, you need light para makabasa ka sa text sa imuhang libro. Tama ba? Kay if otherwise, kung gabi na tapos gusto ka magtuon, you can't read the text kung ngit-ngit, di ba? So the right quantity of light with excellent color rendition and minimal glare are provided good architectural lighting design. which in turn improve productivity and enhance worker satisfaction. Windows and skylights are examples of natural lighting and allow sunlight to come into interior space. This chapter will introduce basic lighting terminology and the procedures of simple lighting design, and this will highlight the material that acquaints the technician with basic design principles. So the first part, a chronicle of artificial lighting, which consists na ay historical perspective, professional organizations, and the standards and codes to be followed. So sa unang panahon, or once upon a time in English, the unit foot candle is a common measure of illuminance. Wood, candle wax, whale oil, coal gas, and kerosene were used to illuminate building interiors. On December 21, 1879, Edison announced the successful development of an incandescent lamp with a baked carbonized cotton thread filament and was the first to develop a commercially feasible electric light. By 1882, his company, the Edison Electric Light Company, successfully demonstrated the use of artificial lighting by powering incandescent streetlights and lamps in approximately 30 buildings in part of London beginning on January 12 and later by illuminating parts of New York City beginning on September 4. In 1939, General Electric introduced fluorescent lighting, an electric light source that is more efficient than the incandescent lamp. The first high-pressure discharge lamp the, that were developed was mercury vapor lamp, known as the bluish-greenish street lamps of the middle few decades of the 20th century. Other forms of gaseous discharge lighting were also developed about that time. So, kaning mga gaseous discharge lighting bala na to ni unsa pay laing examples ani later. So, mo ni ang professional organizations na involved sa lighting design. So first, naatay Illuminating Engineering Society of North America or IESNA. Kaduha natay International Association of Lighting Designers, LALD. Then third is the National Electrical Manufacturers Association or NEMA. And last, the American Lighting Association or ALA. So what are the standards and codes nga involved sa lighting design? So first, natay National Electrical Code. It is a model code that specifies the minimum provisions necessary for protecting people and property from the use of electricity and electrical equipment. It applies to both the manufacture and installation of electrical equipment. And I'm sure familiar pa mo sa kaning National Electrical Code since nagamit man ni sa atong previous nga project or rather maski katong Philippine Electrical Code. Next is the ASHRAE or IESNA 90.1 or American Society of Heating, Refrigeration, and Air Conditioning Engineers Incorporated or Illuminating Engineering Society of North America Incorporated, Standard 90.1. These address energy consumption in commercial and high-rise residential buildings. For lighting systems, the standard defines a number of basic requirements including minimum number of lighting controls, ballast performance, and limits on installed lighting power. So next topic is the elements of seeing. Design of a good lighting system involves application of a blend between scientific principles, artistic skill, and design experience. Optics is that branch of physics that relates to the properties of light and the function of vision. It involves a study of the human visual system and how it interacts with light. The basic principles of vision and light as related to building lighting systems will be introduced. So, mo ni siya ang visual system nato. Ang visual system nato composed of eye, atong mata, then mga optic nerves, kaning murag mga wires, gikan sa mata nato padulong sa kaning part sa atong brain. So this is how it works, the visual system. The eye is the organ that allows a human to sense light and produce electrical impulses. These electrical impulses are sent through the optic nerve to the brain. So na siya impulses dire. Mura siya current kung sa electricity pa. Iya din na siyang i-add to sa brain dayon. The brain is that part of the visual system where the impulses are processed. Each element of the visual system is needed to transform light stimuli into nerve excitations that allow a human to view an object. So, mapod ni ang atong eye. So, the eye functions much like a simple, very crude camera. Rays of light pass through the transparent cornea of the eye and through an opening called the pupil. So, mo ni siya ang cornea, then kani ang pupil. The iris surrounds the pupil and adjusts for the amount of light available. It opens and closes to control the quantity of light the interior of the eye receives, much like the aperture on a camera opens and closes to limit the light to which the film is exposed. Behind the iris is the lens. The lens is a transparent ellipsoidal medium that changes thickness, allowing it to bend and focus the rays of light entering the interior of the eye. The lens narrows to focus light from distant objects and thickens to focus rays of light from objects nearby. The lens concentrates the rays of light on the retina. So, the retina is kani siya. Nimrag dari sa likod sa atong mata. A membrane of the back of the eye. So the retina is composed of nerve cells with photoreceptors. So mo ni siya nga nerve cell, abe. So na siya photoreceptors that are shaped like rods and cones. The rod-shaped photoreceptors sense extremely low levels of light and provide efficient vision in dim light. These photoreceptors do not discern color well, so dimly lit objects are perceived as being uncolored, that is, seen in shades of gray. So, example, ana a case is kanang nagdag-om, tas wala mo'y kurente sa balay. So, ang makita ninyo sa inyong surroundings is like shades of gray lang, di ba? Dili kay ninyo maklaro ang color na niya. So, nga na siya. Example, pasabot ana. These photoreceptors do sorry. The photoreceptors that are shaped like cones provide color vision and respond best to bright light. Higher levels of light are required for the eye to discern color. As rays of light strike the photoreceptors of the retina, they produce electrical impulses that travel from the nerve cells on the retina through the optic nerves to the brain. So kanino? Mga ugat-ugat. So mo ni siya diri mo travel tong electrical impulses padulong sa ato ang brain. There are three different types of cone-shaped photoreceptors in the retina. Each type responds to one of the primary colors of light. So naatay red, naatay green, and naatay blue. In individuals with normal vision, the electrical impulses from each cone blend together to create the sensation of other colors. However, about 5% of the population, mostly males, has defective color vision. Mga laki, agree mo ane?
Yes, sir.
Yes, sir.
Dalawa na sa white, sir. Ang color blindness.
Mm, okay. Abi na ko nga ako ray dili mo agree diri da. Agree di ay. Sige. So color blindness is the inability to distinguish colors. The most common form of color blindness is found in those individuals who have difficulty distinguishing red from green. So karon question. Moto ba mo nga ang bull is colorblind? Again ha, moto ba mo nga ang bull is colorblind?
Murag dili, sir.
Murag dili. Unsa may tanaw sa uban? Hello? Abot ang uban. Sa inyong opinion, anak? Friend?
Yes, sir.
Yes, I man. Sige, kasi makaingon sa reason anong blind man daw, color blind man daw si Bull. Yan na, istorya na. So, ngano nakaingon mo nga blind, color blind si Bull? According diri kang Christian Clint kay dili sila makakita og red. Well, isa na siya. Or rather, mo na siya ang rason. Dili sila makakita sa color nga red. Dili na sila tungod kay, di ba, naman na siya ay matador man siguro tawag anang kano kanang ilang ginagukod no nga gahawid og kanang pulang nga panyo.
Sir.
So dili tungod kay na red ang panyo nga gihawiran sa matador mo nang rason nga iyahan ang gukdon. Yan ang gagukdon bitas kay gakairita na siya sa galihok-lihok. Dili kay tungod red na siya. So karon kabalo na mo nga color blind si Bull sa red. Kadali lang guys ha. Individuals who are completely red-green colorblind see yellows and blues normally, but have trouble differentiating reds and greens. They tend to see reds and greens as yellow. Individuals who are totally colorblind see only black, white, and shades of gray. Next is the electromagnetic radiation. So, light is that form of electromagnetic radiation that allows the eye to see. In fundamental theory, electromagnetic radiation is energy radiated in the form of a wave caused by an electric field interacting with a magnetic field. It is the result of the acceleration of charged particles. Contemporary theory suggests that electromagnetic radiation also behaves as a group of particles called photons. So as you can see, aning a figure na siya table sa na classifications of electromagnetic radiation. So na-discuss na ni sa uban katong previous nga reports. So electromagnetic radiation is categorized by wavelength and frequency. Wavelength is measured as the distance from one peak of one wave to the next wave. It is expressed in meters or nanometers. Unsa gani scientific notation sa nanometer gani? Anyone?
Times 10 to the power of negative 9, sir.
Okay, thanks Kirby. 1 nanometer is equal to 1 times 10 to the power of negative 9 meters. 1 inch contains about 25.4 million nanometers. Frequency is the number of wave cycles per second. So pila ka waves ang iyahang nabuhat per second. So muna siya ang frequency. It is expressed in units of hertz. TV and radio waves are several meters long with frequencies ranging from 10 kHz to 300,000 MHz. In contrast, visible light waves are only about 0.00005 meter in length. So as you can see, ang types of electromagnetic radiation. So natay TV and radio waves, mo na siya ang first nga electromagnetic radiation and gamay na siya og frequency. Then next is the microwave nga gikan sa atong cooking or radar sa telephone and other signals. Next is the infrared, which is transmitted heat from sun, fires, and radiators. And fourth is the visible light. So direta makakita sa ato ang mga colors. Next is the ultraviolet, which is absorbed by the skin, gikan na siya sa sun nga energy, and are also used in fluorescent tubes. And X-rays is used to view inside of bodies and objects. And lastly, ang gamma rays are used in medicine for killing cancer cells. So, kaning ultraviolet to gamma rays are dangerous levels na ni siya sa electromagnetic radiation. So, dili maayo nga ma-expose kag dugay ani nga mga type of radiation. Wavelength and frequency of electromagnetic radiation are dependent on the source emitting that radiation. Large antennas such as those found on the tops of buildings and mountains must be used to generate radio and TV waves. Gamma radiation, the shortest and most powerful form of electromagnetic radiation, result from changes within the nucleus of the atom. The sun and electric lamps are light sources because they transform energy to the visible electromagnetic wavelengths that can be perceived by the human eye. Most light sources emit electromagnetic radiation composed of different wavelengths of light. So, for example, sunlight striking the Earth's atmosphere is made up of ultraviolet, about 5%, then visible light, about 45%, and infrared, about 50% na siya nga radiation. So, mo na yung composition sa sunlight. Ordinary incandescent lamps also emit radiation of different wavelengths in varying magnitudes, principally in the visible light and infrared sectors of the electromagnetic spectrum. Next is the visible light spectrum. So the visible light spectrum is the section of the electromagnetic radiation spectrum that is visible to the human eye. So example na to ani is rainbow. So unsa may colors nga ga-consist sa rainbow?
Roy G. Blag, sir.
Yes, Prince. Unsa imo?
Red, hello sir, madunggan ba?
Dawag ka.
So, red, orange, yellow, green, blue, indigo, violet sir.
Okay, good. So isa ang rainbow sa atong example sa kaning light spectrum or visible light. Thank you sa answer. So, naatay next topic of behavior of light. So, sa kaning nga figure nga naa diri is natay source of light. Ani siyang bulb. Then natay object surface sa isa ka object, then natay reflected light padulong sa atong mata. So, sa kani nga scenario, naa siya'y upat ka characteristics nga involved ani. So, natay luminous flux, luminous intensity, illuminance, and luminance. So, unsa na sila? First, ang illuminance is the amount of light incident on striking a surface. So, there siya na. Although an object may be illuminated, the eye cannot see it without visible light leaving reflecting off the object in the direction of the viewer. Ang kaduha, luminance, is the amount of light leaving an object. It is how bright an object appears. The visual system perceives luminance, not illuminance. That is, the eye sees visible light leaving the object, not the light arriving at the object. So, ang reflection, bali sa eye, ay rather sa object, ang atong makita. So, naay tulo ka properties sa ato ang behavior sa atong light. So, first, natay ginatawag nga reflectance. Reflectance is the ratio of reflected light versus the light striking the surface. For example, the reflectance of a dull black surface may be about 10%, while reflectance of a polished white surface may be 0.85 or 85% is reflected. Specular reflection occurs when light is reflected off a polished or mirror-like surface. That is, the reflected image is maintained. So, unsa pay objects nga example nga kanang ga-display sa property of reflectance aside sa mirror? Again ha, i-repeat na kong question. Unsay object nga ga-display sa property of reflectance aside sa mirror? Water. Okay, isa na siya, Jason. Thank you. Sa pay uban? Unsa pay lain, guys? Aside sa water nga gingon ni Jason. Aluminum foil. Sakto nga pagka-obserba na agyod siya reflection. Ikaduha, ang glass na agyod po siya reflection. Okay, good. Reflector. Yeah, except sa mirror. Sakto na. Marbles. Marbles. Murag naa siya. Tama. Mayo. Sige, so cellophane, wala kayo ang cellophane. Kung mo-reflect siya, I think gamay ra kayo nga percentage ang iyang reflectance kanang cellophane. Okay, thank you sa inyong mga answers, guys, ha. So next property sa behavior of light is, So napatay tayo laing types of reflectance. So napatay specular, natay diffuse, transparent, and translucent. So reflected light can be specular or diffuse. Light that is transmitted through the glass will behave in a transparent or translucent manner. So next nga property sa ato ang behavior of light is the transmittance. Kung based ani nga figure, mura siya nilusot sa surface sa object. So transmittance is the ratio of light transmitted through the body versus the light illuminating the surface. When light strikes ordinary window glass at an angle perpendicular to the surfaces, the transmittance is about 90% of the light striking the glass is transmitted. A transparent body transmits light through it without distorting the image. A translucent body transmits light but obscures the image because the light is scattered. Ordinary window glass is an example of a transparent medium while frosted glass is translucent. Next property is the absorptance. It is the ratio of light absorbed versus the light striking the surface. For example, the absorptance of a dark black surface may be about 90%, while absorptance of a white surface may be 5%. Absorbed light manifests itself as energy by raising the temperature of the body receiving the light. So example ani is kanang times nga magsuot tag kanang black nga t-shirt on a sunny day. Diba kung magsuot tag itom tapos lakaw din ta sa kanang init kaayo like udto. So I'm sure nabantayan ni ninyo nga grabe kaigang atong pamati ana. Diba? Tama ba ko?
Sir, yes, sir. Grabe kayo kang magmagitang, sir.
Sorry.
It's because kanang light coming from the sun is gi-absorb sa fabric nga black. So kanang na-absorb nga energy karon is gikan sa light, nahimo na siya og thermal energy. So mo nang mabati ta og kainit sa ato ang sanina. Karon kung i-compare na nimo sa white, kung magsuot kag white sa init kaayo nga panahon, unsa may inyong bation? Kuan ba siya kanang igang ba siya or arang-arang ra compared sa nagsuot kag black?
Mutagos, sir.
Mas presko na, sir.
Arang-arang na, sir.
Fresco,
Mas
sir.
less na siya.
Init
Mas
sabon,
less
sir.
na siya. So less na ang iyahang ka-absorb nga light sa sun. So dili na ta igangon kaayo unlike sa kanang magsuot tag kanang dark colors or black. So karon, when a translucent or transparent body is illuminated, the illuminance striking the surface will be reflected, absorbed, and transmitted. So reflectance plus absorptance plus transmittance is equal to 1. And when light strikes an opaque surface, the illuminance will be reflected and absorbed but not transmitted. So example sa properties ani nila no is first kaning glass of water. So ang light mo pass through completely siya sa kaning glass. So naatay reflectance, then naputay absorptance kay murag mohayag man gamay ang glass, di ba? Then lastly na siya transmittance kay nilusot siya sa glass. Dere sa translucent object portion sa light ang ni-pass through. Then na siya a bit of reflectance nga property, then some of the light are absorbed in this material. And lastly, kung opaque surface or objects, there is no light that pass through the object. So wala siya nag-exhibit og transmittance nga property, but only reflectance and absorptance lang. So reflectance kay tungod nakita na nato ang color sa kaning apple para ani nga case. The type of light is striking the surface, the properties of the surface receiving it, and the angle at which the light is received dictates the amount of reflectance, transmittance, and absorptance. A shiny or polished object will tend to have higher reflectance. A light-colored surface will have greater reflectance than a dark surface, and an increase in incident angle will tend to increase reflection. So it is measured from perpendicular to the surface. A light source can produce diffuse or direct light. Diffuse light is light that is widely spread or scattered. It is the type of light available on a hazy day. Direct light is strong, directional type of light. It is the available type It is the type available on a cloudless sunny day where shadows are well defined. So kani siya sa kaning figure nga na dire mo ni ang direct light nato no. So dili dagom natay direct exposure sa sunlight. While kung naa kay surface of an object, um ang sunlight is spread siya sa kaning object. So mo ni siya example sa diffuse. Then diri po sa third nga image, pag cloudy, kung kabantay mo no kung cloudy, nagya po siya hayag gamay. So ang light ana nga coming from the sun is absorb siya sa cloud pero napay portion ana nga kaka-transmit or gakalusot pa sa cloud. So mo nang naay times nga hayag pa gamay despite nga nag-cloudy. Next is the color of light. Color perception is the ability to distinguish and interpret different wavelengths of visible light. Artificial and natural light or sources are composed of many wavelengths having varying magnitudes. An opaque object will selectively absorb different proportions of each of these wavelengths and reflect the remainder toward the viewer. So an object that absorbs all of the longer wavelengths and reflects the shorter wavelengths will be perceived as violet or blue. The perceived color of an object is dependent on the wavelengths emitted by the light source, the wavelengths illuminating the object, and the selective reflectance of the object's surface. So, as you can see sa figure nga naa, so mo ni ang primary colors of light nga consist of red, green, and blue. A light source producing a blend of wavelengths that are evenly distributed across the light spectrum is perceived by the human eye as white or normal colors. So this light is actually made up of all wavelengths of visible light. So as you can see, no, kung i-combine mo ang blue and green is maka-form siya og cyan, then blue and red is maka-form siya og magenta, and kaning green and red is maka-form daw siya yellow. Pag i-combine nimo ang tulo ka primary colors of light, maka-form siya og white. Mo ni kaning sa number 7 sa center nila. So kani nga mga type of colors is ginatawag ni sila nga additive nga colors. So napo tay ginatawag nga subtractive nga colors. The pigments or the colors of pigments are yellow, magenta, and cyan and are opposite of the colors of light. Colors of pigments are subtractive. So subtractive si yellow, cyan, and magenta. And they can be used in various combinations to produce any other color by subtracting a color. When the colors of pigment are combined together, they produce black. So, bale, kani sila nga colors are opposite siya sa kaning primary colors of light or the additive colors. A chromatic light source emits a fairly even distribution of all wavelengths of light. Most light sources are not fully chromatic. A monochromatic light source produces visible light in a very small range of wavelengths. A red light emits predominantly red wavelengths, a green light gives off predominantly green wavelengths, and so on. So, murag shades sa isa ka color ni siyang monochromatic. Next topic is the color quality. A light source that produces a blend of wavelengths evenly distributed across the light spectrum is perceived as white light. White light renders all colors. That is, a multicolored surface illuminated by a white light will render all colors evenly. Generally, a good quality light source renders all colors uniformly. Madali lang. A light source of poor color quality renders the different colors unevenly. Light sources do not produce an even distribution of wavelengths across the light spectrum. Some light sources render all colors better than others. Ordinary incandescent lamps found in homes are generally strong in yellow, orange, and red wavelengths and somewhat deficient in green, blue, and violet wavelengths. The color emitted by fluorescent lamps are used for general lighting in most offices and classrooms typically varies by type of lamp, but they are generally strong in red, green, and blue wavelengths. High-intensity lamps commonly used to light remote street intersections emit mostly yellow wavelengths. Even sunlight may pass through a reflective coated window glass that removes some of the wavelengths in the light spectrum. So there are two methods that are used to rate the quality of color emitted by a light source. So natay ginatawag ng color temperature and color rendering index. A third technique involves review of the spectral power distribution curve. This is a method of appraising the colors emitted by a light source by evaluating the power emitted in small wavelength groups across the light spectrum. So makita nato ang example aning spectral power distribution curve later. Next is the visual acuity. Visual acuity is the ability to distinguish fine details. It is the keenness of vision that is necessary to perform tasks such as reading, writing, drafting, sewing, or surgery. Technically, visual acuity is measured as the ability to identify black symbols or letters on a white background at a specific distance as the size of the symbols are varied. So, sa katong mga naka-eyeglass dire no, nakabantay ba mo nga di ba magpa-check man ang doktor no? Tan-aw man ang doktor kung makabasa mo ani yung mga text sa layo. So yung ani ang example sa atong visual acuity. So, okay. So for example guys, kani mabasa ba ni ninyo kaning first nga line?
Yes, sir.
How about
Sir.
kaning ikaduha?
Yes, sir.
Kaning ikatulo?
Yes, sir.
Yes, sir.
Kaning ikaapat?
Dili na kayo.
Kaning ikalima? Di na
Dili
gyud.
na. Dili na, sir.
So, muna siya ang example sa visual acuity. So, gimension ako tong mga naka-eyeglasses because it is one way na ginatanaw sa doktor kung makaklaro pa ba ta. Diba kay mag-check up na, magpa-check up ta sa doktor no. So, basa man tag ka ng dagko nga letters. Then, magkadugay, magkahinay-hinay, magkagamay ang mga letters hantod sa pinakagamay. Then, di rin ka kuan din sa doktor nga, okay, mao ni ang grado sa imong mata. Diba? Kamo na kay glasses, agree mo ana?
Yes, sir.
Or walay, abi na ko way ga-glass diri nga section. So, next nga topic is the characteristics of artificial lighting. Sorry. So, in lighting industry, natay gina-define nga term for lamp and bulb. So, sa inyo ha, in general term, ang lamp and bulb, do they sound nga murag synonym para sa inyo? Yes or no? Para sa inyo, pareha siya. Pero pag abot sa lighting industry, naa siya'y difference. So according dere, a lamp is a device that generates the light. Although frequently called a light bulb by the layperson, the term lamp rather than the bulb is used in the lighting industry to avoid confusion when describing a light source. So device ang lamp. So kaning bulb is the glass portion of a lamp that encloses and protects the working parts of the light source, whereas the lamp is the source of light. So, refer ta aning light bulb nga naa dere. So, ang bulb daw, according by definition, is kaning glass nga portion. Aning milya. Then, ang kaning sa sulod niya is considered as the lamp. So, mo na siya difference niya pag abot sa lighting industry. So natay duha ka categories for lamps. So natay first incandescent lamps and gaseous discharge. So ang example sa incandescent lamp is kaning naa sa background sa ato ang presentation. So incandescent lamp, any of various devices that produce light by heating a suitable material to a high temperature. When any solid or gas is heated, commonly by combustion or resistance to an electric current, it gives off light of a color or spectral balance characteristic of the material. So, most commonly, ang kaning mga incandescent light have yellow to orange na mga light colors. Kabantay pa ba mo og incandescent lamps na ginabaligya karon? Kabantay pa mo? Or wala na?
Sir, unsa gi difference nila ng light karon? Unsa difference ng incandescent o gaseous discharge?
Mabot ang tadiya sa gaseous discharge karon. Dali lang ha. Yes. Common karon na panahon na is LED lights na siya. So, ito na siyang matakol ganong LED na. So next is the gas discharge lamps or the gaseous discharge lamps. They are a family of artificial light sources that generate light by sending an electrical discharge through an ionized gas such as plasma. The character of the gas discharge critically depends on the frequency or modulation of the current. Typically, such lamps use noble gas such as argon, neon, krypton, and xenon, or a mixture of these gases. Most lamps are filled with additional materials like mercury, sodium, and or metal halides. So, mani ang circuit sa isa ka gaseous discharge nga lamp. So, by operation, the gas is ionized and free electrons accelerated by the electrical field in the tube collide with gas and metal atoms. So, wali, kung maka-on na ang source, natay free electrons nga mo travel padulong dire. Some electrons in the atomic orbitals of these atoms are excited by these collisions to a higher energy state. When the excited atom falls back to a lower energy state, it emits a photon of a characteristic energy resulting in infrared, visible, or ultraviolet radiation. Some lamps convert the ultraviolet radiation to visible light with a fluorescent coating on the inside of the lamp's glass surface. The fluorescent lamp is perhaps the best known gas discharge lamp. So I'm sure nakakita na tag fluorescent lamp, no? Or maski fluorescent tube.
Yes, sir. Kita na, sir.
Yes, so muna siya ang example sa ato ang gaseous discharge nga lamps. So napay other examples para sa gaseous discharge lamps. So muna sila. So ang gaseous discharge lamps are further divided into two subcategories. Natay low pressure lamps and high pressure lamps or high intensity discharge lamps. So kinsa na ba'y nakakita ani na mga suga sa tindahan or even sa inyong balay?
Kanang right side, ay left side, sir, or right side?
Sa low pressure lamps lang, sir.
Oh, yes.
Nakita
kanang
na ninyo
left side.
halos sa ning low pressure lamps?
Yes, sir.
Yes, sir. Sa low side. Ginagamit ito na dahil, sir.
How about kining high intensity discharge lamps? Nakakita mo ani?
Sa ano, sir? Sa mga company, sir. Sa mga sa underground na kwan, sir. Sa bodega.
Ako, pag ko kita anak nila ba? Sige. So at least kabalo na mo unsay examples aning gaseous discharge nga lamps. So in buildings, napo tay ginatawag nga term nga luminaire and light fixtures. So unsa ni sila? A luminaire is a complete lighting unit which consists of a lamp or even lamps. Then napo siya lamp sockets, any lenses, refractors or louvers, any balas kung naa manggali, and the housing. So kaning figure nga na diri is an example of a luminaire. Actually, kanang pinlight ninyo, isa po na siya ka-example sa luminaire. Luminaires include fluorescent troffers, downlights, spot or accent lighting, task lighting, and outdoor area of flood lighting. A light fixture is the luminaire less the lamps. So kung walaon ninyo ang lamp dira sa picture, light fixture na ang tawag anak niya. So that consists of structural parts of a luminaire including any lenses, mounting supports, wiring, balas, but wala gyud ang lamp. In street and road lighting, the term lantern is also customarily used to describe a luminaire. So dili na luminaire ang tawag ana sa street lights kundi lantern daw. Okay. So na kuha na ba? Makita ba nato nga or nasabtan ba nato nga kani nga mga terms mo ni gipasabot? So far so good. Or murag
Yes.
dili so far so good. Sige, so ako na pimutan na no. Question of the day, Char. When you buy a bulb, which trait do you consider when you want to have a brighter bulb or light? So assuming na mo'y box of a light bulb, so unsa man nga numbers diri imong gi-consider kung gusto kag kanang hayag nga suga?
What, sir? What? By what?
Light?
Kagawad.
What?
Sa what, sir?
Logic. Nice one, price.
Ay, nga, sir. Dagan kita ako, sir, bay. Lang, sir.
Jason, sa imo, Jason. Okay na Lloyd, okay na Lloyd. Jason, unsay imong Jason?
Sa kanang 1,360 lumens, sir.
Kanang 1,360 lumens. Nganong kay nung kana Jason?
Kay since ang watts kay gina-measure niya ang amount sa energy, sir. Then, ang lumens is kanang gina-measure niya ang amount sa light nga ga-produce bitaw, sir. So, the more lumens nga ga-produce, then ang kahayag po niya, sir, kay taas po diyang kahayag.
Okay, good observation Jason. Thank you. So karon kabalo naman no. Kung gusto mo kanang hayag nga suga, pangitaan ninyo ang suga nga dakog lumens. Kay mo man ang indicator sa brightness sa atong light. Dili ang watts. Kabantay mo ani guys, kani 'di ba na may 12 watts nga LED, naapoy 22 watts aning I think CFL ni siya. Then kanina yun 98 watts nga murag incandescent man siguro ni no. Kasabot mo unsay pasabot ani nga values nga naa dire?
Wala, sir.
Ako nasabtan ani guys ha. Kani daw nga mga wattage sa suga sa 12 watts nga LED and 22 watts nga CFL and 98 watts nga incandescent bulb mo produce daw sila og ingani ka hayaga nga lumen nga suga or lumen sakto ng observation nimo Paul. So if you want to save energy, asa man mo go? Sa LED, sa CFL or incandescent? If gusto ninyo og kanang kuan savings, okay, LED. Tama. So review lang unsay formula sa energy. Jason.
Power times time, sir.
Sige, thank you Jason. Unsa may unit sa energy?
Kilowatt hour, sir.
Di kilowatt naman diretso. Okay, kilowatt hour. Or kung dili, or pwede po na siya watt hour. Kilowatt hours kung dagko na. Okay? So, proceed ta. So, discuss na to ang first nga characteristic sa atuang artificial light. So, natay ginatawag nga light output. Luminous flux is the measure of the perceived power of light expressed in lumens or LM. It is adjusted from the total power of radiant energy emitted by a light source to correct for differences in sensitivity of the human eye to different wavelengths of light. Technically, a lumen is defined as the quantity of light given out through steradian by a source of 1 candela of intensity radiating equally in all directions. The steradian is the SI unit of solid angular measure, where there are 4 pi or about 12.56 steradians in a complete sphere, or about 7.96% of the area of the sphere. The lumen is most commonly used for measurement of total output of a light source. A 100 watts soft white incandescent lamp and 23 watts nga compact fluorescent lamp emit roughly 1,500 lumens. So muna ta itong question earlier, no? Next is the candela. Candela is the SI unit of luminous intensity. That is, the power emitted by a light source in a particular direction. One candela is 1 lumen per steradian. It differs from the lumen in that it is a measure of light flux in a specific direction. Technically, a candela is the luminous intensity in a given direction of a source that emits a monochromatic radiation with a frequency of 540 times 10 to the power of 12 Hz, and that has a radiant intensity in that direction of 1 over 683 watt per steradia, which describes how to produce a light source that emits 1 candela. Originally, this unit was expressed in terms of candles. As a result, the candela is sometimes improperly called candle power, which was formally defined as the light emitted from a wax candle. The candela is roughly the amount of light generated by a single ordinary dinner candle. So here is a comparison sa ato ang light output nga properties. So in summary, ang candela indicates the strength of the light emission. Ang lumen describes the amount of light that is radiated. So mag-base siya sa okay. Then natay lux diode, which indicates the illumination intensity of an area. So mag-base ni siya sa katong surface of the object. A lumen is the amount of light striking a 1 foot squared surface that at all points is held 1 foot away from the flame of a standard candle, or roughly 1 candela of intensity. Luminous efficacy. It is the ratio of light output of a light source to the electrical energy consumed to produce that light source. It is expressed on units of lumens per watt of electric power, and thus it is referred as LPW. LPW, light output in lumens divided by power input in watts. Luminous efficacy is a good measure of the efficiency of a bare lamp. It will decrease over the life of the lamp because lamp output declines over time. So first example, a 40 watts incandescent lamp that emits 505 lumens of light. So pila ang luminous efficacy ani? So para ma-solve na, ang lumens na given niya, i-divide lang sa wattage sa atong suga. So 505 divided 40 natay 12.6 lumens per watt. Next is the fluorescent lamp, ay fluorescent lamp with 40 watts and 4 watts sa balas that emit 3,050 lumens of light. So sa kanina case no, ang luminous efficacy is lumens kani siya divided by the total power sa tong fluorescent lamp. So sa case ani, gi-add up ang power ni fluorescent og sa iyang ballast. So mo nang 44 ni siya. So i-divide lang na siya na kay 63 lumens per watt. Nakuha ra ba ning duha so far?
Yes, sir.
How about ang uban?
Yes, sir.
Wait lang, sir. Walang sa 44 niya, sir. What's siya ba? Naputol siya ganina, sir. Pwede pa balik, sir.
So balik ko ha sa part
Sa
3.
44 watts, sir.
So
Walang 44 watts.
So ano yung 44 watts na itabo ni siya kay gi-add up ang power sa fluorescent lamp and kaning sa balas niya. So mo nang naay 44.
Sige, thank you.
Sa ay balas, 40 lang ni siya. Okay, isa pa'y uban. So sige, how about kani? Pila man iyang luminous efficacy? Ani? Part C. Jason ra man gyapon, lahi na pud. Pila ang luminous efficacy aning part C? Mhm. May tanatagin sa paywalag answer B. Sige, ikaw daw, Joey.
Kwan sir, 113.3
Unsa unit?
LM over W.
Okay, good. Ayaw kalimot sa unit ba na to guys ha. Walay correct answer ng Y unit. So again, ang luminous efficacy sa kaning LED light na to is 113.3 lumens per watt. So basically, 1,360 divided by 12 lang na siya. Nakuha ba na to?
Yes, sir.
Dali lang ha. Sa una, Edison's first lamp had a luminous efficiency of 1.4 lumens per watts. Nga na siya ka-cute. Today's lamps fall in the range of 10 for incandescent and 180 for low pressure sodium. So mana ang ilahang luminous efficiency. The theoretical maximum for luminous efficiency of a white light is 225 lumens per watt. Next property, correlated color temperature. The color of light emitted by a light source correlates to the temperature of the emitting source. In physics, a black body is theoretically ideal body that perfectly radiates energy. As the black body is heated well above room temperature, it begins to incondense. That is, it emits visible light as a result of heating. So question, which color is the hottest? Or what color is the hottest?
Blue, sir.
Yes, blue ang pinakainit na color. Makita po ninyo siya sa kanang mga stove ninyo no kung magluto mo. Kung mapansin niyo kung bago pa ang inyong LPG, blue ang inyong kakakita sa inyong kalayo. So, init na kayo na siya nga color sa kalayo. The color of a lamp can be rated by its correlated color temperature or CCT in degrees Kelvin, the SI unit of temperature. The CCT of a light source is the temperature in Kelvin at which the heated black body matches the color of the light source in question. So, natay table 20.3 that shows the approximate color temperatures in degree Kelvin of various theoretical black body, natural and artificial light sources. So, makita ninyo dari no, ang blue is taas kayo o temperature. So, pasabot siya ay pinakainit. Next is the color rendering index. It is a method of numerically comparing the color distribution of a light source to a reference lamp. The reference lamp emits light over the full visible light spectrum at the same color temperature as the light source is being tested. Light emitted by the test lamp is compared to light emitted by the reference lamp at 8 specific colors. A deficiency in illumination of one or more of these specific colors decreases the CRI of the test lamp. In theory, a lamp with a higher CRI more closely emulates the reference lamp and provides a better color rendition. A lamp with good color distribution has a CRI of at least 80. However, the principal drawback of the CRI is that it does not specify deficiencies in any specific color. For example, a lamp may have relatively high CRI but be missing a color. Also, it is meaningless to compare the CRI of lamps with significantly different color temperatures. So, napo tayo table 20.4 nga nag-show sa approximate nga CRI sa kada source of lamp type or source of lights. So, as you can see, pinakataas ang natural light. Next is the spectral power distribution data. It is a graphic presentation of the quantities emitted by a lamp by wavelength component. These curves are a plot of radiant power versus a specific wavelength across the light spectrum. They provide a visual fingerprint of the color characteristics of the light emitted by the source over the visible part of the spectrum. Spectral power distribution curves for specific lamps are available from the manufacturer. So as you can see sa kaning figure nga naa dere, na siya'y laylay nga source of light. So na siya'y individual nga spectral power distribution data. So for example, sa incandescent, namatay wavelength dere sa ubos na natay radiant power in microwaves per 10 mm per lumen. So kung imong i-energize ang incandescent lamp, natay mixture of colors. Natay blue, green, yellow, orange, and red. So assuming red ang pinakataas diri. So the same goes sa ubahang mga source of light. So si metal halide na siya'y ultraviolet, violet, blue, green, yellow, orange. Then gamay nga red. So lahi-lahi siya kada source of light. Next is the rated life of a lamp. It is a median life expectancy expressed in hours. It is the cumulative time that lapses before 50% of a representative group of lamps has failed and the other lamps in the group continue operating. For example, a 60-watt soft white incandescent lamp can be expected on average to burn for 1,000 hours. Based on continuous testing of lamps in laboratories, the 1,000 hour rating is the point in which time when 50% of the test samples have burned out and 50% are still burning. In other cases, rated life is difficult to determine because these lamp types will continue to emit light but get dimmer and dimmer with time. That is, they do not burn out. In such cases, the manufacturer normally arrives at the life by determining the most economical point for replacement in the life of the lamp. So, ang information sa iyang rated lamp is usually makita sa specs sa kaning suga nato or sa kaning sa internet bitaw. Lamp life will generally decrease each time a lamp is switched on and off. A continuously lit lamp will normally last much longer than one that is switched on and off regularly. Because of energy cost, this reduction in life does not warrant leaving lights on in an unoccupied space. It does, however, influence the lamp life test results. Testing is typically performed in 3-hour start intervals for fluorescent lamps and 10-hour start intervals for most other lamps. Life of incandescent lamps will be affected by the voltage they operate versus the voltage for which they were designed. Slightly lower voltage means increased life because of cooler operations, but this reduces light or lumen output. Life of fluorescent and HID is greatly affected by the type of ballast. So dapat ang lamp o ang ballast is mag-match gid siya para kuha na to iyahang lamp life. So example 2. A lamp manufacturer's specifications for a 40 watts fluorescent lamp indicates an output of 2,680 lumens, a rated life of 20,000 hours, and a cost of $6 per lamp. Data for a 150 watt incandescent lamp indicates an output of 2,850 lumens, a rated life of 750 hours, and a cost of $2 per lamp. So when in use, it is anticipated that these lamps will be operating at 10 hours per day or 220 days per year. So first na step, para ani, i-approximate the time period that elapses before replacement is necessary. So for incandescent lamp, the wattage, or rather the time, or the rated life, is divided by 220 days per year times 10 hours. For fluorescent, so sa incandescent, no, sa gamay raman iyang rated life, so ang iyang answer diri is 0.34 years or 4.1 months. So in a short period of time, makapuli na sad kag bag-ong suga. How about sa fluorescent lamp? So sa fluorescent lamp, iyang rated life is 20,000 hours. Then divide na to sa 220 days per year times 10 hours per day. So approximately 9.1 years, 9.1 years para mag-replace sa lamp. So next, approximate the cost of each type of lamp over a 10-year period, assuming you. So in 10 years, i-divide na to kung pila ka lamp atong kailangan mapalit pagka 10 years. So that's roughly mga 29.4 lamps, then pila ang imuhang gasto. So multiply lang ng $2 o kanang sorry na interrupt. So nakay 29.4 lamps na imong magasto o puli para sa kaning incandescent lamp. So ang presyo sa isa ka lamp is $2. So multiply nimo ning 29.4, that's roughly mga $58.80. For 40 watts ng fluorescent lamp, sa period of 10 years, then rate dayon 9.1 years per lamp. So makapuli na ka og mga 1.1 lamp over 10 years. So times presyo niya nga $6 per lamp. So ang imo ra magasto over the 10 years is only $6.60 only. Unlike sa kaning incandescent lamp nga for 10 years makagasto na ka og $58.80. And last characteristics is depreciation of lamp output. As lamps operate, the luminous flux or lumen output will increase. An incandescent lamp operator light output degrade to about 85% of the lamp's initial lumen output. With fluorescent and HID lamps, lumen depreciation will vary by lamp type size, and use. Degradation to 60 to 80% of the lamp's initial lumen output is common at the end of the fluorescent lamp's rated life. Degradation to 50 to 70% of the initial lumen output is typical at the end of the HID lamp's rated life. Lumen depreciation will also be affected by dirt and dust in the environment. Lamps in soiled or dusty industrial or outdoor environment will become covered with dust and soil coating. So lamp output will depreciate further. Usually, planned maintenance programs are established to replace lamps at the end of their useful life to maintain proper illumination levels, and this process is called relamping. So that ends our topic for tonight. So, are there any questions?
And so far, sir, pero kailangan pa ipasink in ng mga info.
Sige lang, para masik-in ninyo, kaya na ko'y assign itatag. So, mo yung assignment. So, magbase ni siya sa inyong balay and sa lamps or bulbs of your choice. Approximate the time period that elapses before replacement is necessary and approximate the cost of each type of lamp over a 15-year period, assuming the use and lamp costs remain constant. Consider all the rooms available at your house and outside sa balay. Excuse me. So, ang i-consider lang nato aning assignment guys ha is the first floor lang sa inyong balay. Ayaw na apila ang second floor kay medyo unfair na siya sa uban nga na second floor kay madako man ang trabaho ana. So, bali, ang ingani akong gusto makita, no? So, mga calculate mo na ninyo, no? So, example na, may separate niya calculation sa kada kwarto sa inyong balay. So, let's say, bedroom. Mo yung calculation for bedroom. Next, mo ang calculation for bathroom. Next, mo ang calculation for kitchen. Work ana ba? Na-picture out ninyo akong pasabot? Or nasabtan ba ninyo akong gusto ipasabot? So, you are encouraged to go out or to any hardware and select your lamp or even search the internet. Provide the specs of the lamps you had chosen and attach it on your assignment. You may encode or write your assignment on a sheet of paper and take picture. So, ang deadline ani is 2 weeks from now. So, 2 weeks na to. May 4. That's May 4. Okay ba ta?
Yes, sir.
Okay, so are there any questions with regards to assignment? Napabatay questions about sa assignment? I guess wala na.
I think for now, sir, wala. I-PM na lang naman if na.
Sige. Ana lang. Kadali lang ha. Sige, so before di ko malimot, pagka after na sa atong discussion kaning sa atong chapter, mag pre-final exam ta. So that's roughly mga 3 weeks from now. Tapos after ani nga topic na atay reporting, then maybe next week or next week maghatag nako sa inyong project for the final term. So tanawon sa nako kung by group ba ni nako or by member ni or by individual ni siya. So mag-announce ako either next week or next week about sa project na to. Sa pabaylain ba? I guess wala na. Jason.
Sir, about sa midterm exam, sir, ba, pwede may mga yung solution natin, sir?
Solution gid. Solution gid, Jason, dili gid ang answer.
Ay, with answer na siya, sir.
Aha. So, sige. Pero matatauran pa kay letter mo gud akong gisulat mong gud.
Okay, sir.
Sige.
Thank you, sir.
So, I think wala tayo laing questions, no? So, if none, so pwede na ta mag-class dismiss. So, manihapon na tang tanan og salamat sa pag-attend sa inyong klase karong gabi. So, bye-bye.
Sir,
Thank you, sir.
Thank you, sir.
Bye, sir.